GR IAS Academy.
"100 days, 100 themes, one goal UPSC Prelims." Hello everyone, welcome back to Mission Surya. This is day 24. In this program we are going to discuss current affairs completely from prelims perspective. So let's get started. Our next topic is directed energy weapons. So what are directed energy weapons? They are highly advanced military system that uses electromagnetic energy. So what is electromagnetic energy? See, if you notice electromagnetic energy, usually high speed lasers, acoustic weapons, these all weapons use high speed electromagnetic energy and they operate at the speed of the light. So if they are operating at that much speed, obviously there will be game changers in the modern warfare. So how? So when they are operating at that much speed, they will have instantaneous impact. They will have instantaneous impact. So what are the types of energy used for our dues? So laser beams, microwave beams, particle beams and acoustic weapons. So what are laser beams and microwave beams? So these will be using high focused electromagnetic energy, laser beams. So when they use high focus, this is some target, let's say it is some drone. Let's say some drone is there. This is some drone. So when we are using some laser, high energy laser, so since it is moving at the speed of light, we can target any target in instantaneously, within seconds we can destroy the target, whether it is a drone, whether it is a missile, whatever it may be. That much fast it is. And even it does not produce sound. So even without much impact like noise pollution, we can operate these. So this is our equipment which uses our electromagnetic energy. So if you notice, this is high energy laser. Here high energy laser HEL is used to target and destroy the target. Here we are using microwave technology to destroy the drones. So this is how we are targeting different targets and we are destroying them. If you notice, they can be used against different targets like drones and UAVs, satellites, missiles and many more. And here if you notice, human targets which uses non-lethal system. What is non-lethal system? Which allows our weapons not to destroy the target but to make them inactive. So that makes it non-lethal weapon. So what are the advantages of dues? So as we already discussed, it gives us an advantages of impacting any target instantaneously. So the point we notice that is there, we don't have to wait. We can instantaneously target the target and destroy it. Okay? So silent and invisible operation. Since it operates in the speed of light, obviously it will be very silent and invisible for the naked eye. So we can operate it as under silent conditions. And so since it is using only electromagnetic energy, it's not using any ammunition, so the cost per shot will be efficient, very reduced, very less. So yeah, this is our one of the advantage. And since no ammunition requirement is there, only power supply is there, obviously it is efficient, and but we also have limitations in this. So since it is operating at the speed of light, so what happens? It will be weather sensitive. So why it is weather sensitive? Let's say if we are having some rain or some dust or fog or mist. So we have some weather scenario, weather phenomenon. So what happens? We can't focus because it uses highly focused electromagnetic energy. If there is some disturbance, how can it operate? So that will be one challenge. And since it is not using any ammunition, what will happen? It uses power. So more power will be utilized to operate it. So obviously it will be power intensive. And then right now the technology is operating at short range. So if the target is more, if it is long range, it is very difficult for us to operate these high energy lasers or other weapons. So these are yet to be developed more. So as of now, what is its current status? Okay, so let's see what is its status globally. So if you see that DUEs are mostly experimental, means they are not operational everywhere. They are operational for few countries and nearly operational for few countries. If you notice, few countries have already some DUEs which are operational, like USA has Helios, China has Silent Hunter, Russia has Persevat, Israel has Iron Beam, and India has completed successful IADWS trials. So let's move to the next slide. So what is chess? Chess is one. So let's see about chess. What is chess? Chess is a special wing of DRDO. Chess is a special wing of DRDO which employs in producing DUEs, high energy lasers for our DUEs. So it also uses particle beams and other technologies for our air defense. So what else it does? It collaborates with other companies like Bell and BDOC. For what? They collaborate to develop DUEs and other weapons for our air defense. So let's move to our next topic, physical AI unit. So what is physical AI concept? You already know AI. AI means what? Artificial intelligence. So humans have intelligence, but we have developed intelligence for our computers. So usually AI is stored in servers or cloud. I think already you will be using OpenAI projects like ChatGPT, Gemini, all those apps. What are those? Those are AI applications. So we are already using AI applications. So why is there need for us to develop something like physical AI which is integrated with machines? So physical AI concept is nothing but integrating AI inside the machines instead of in the cloud or servers. We have already implemented it, like in the Tesla car, self-driven cars. So already this is existing topic. So why is it in news? Because our ARM company is focusing on developing physical AI to target robots, to help in our daily uses. So what is the use of this physical AI? So this on-device AI uses ARM design processors. So this processor is nothing but a small chip which is used in some robot. Let's say robot. So what does that robot do? Instead of going to some cloud and getting answers, it uses directly the intelligence which is embedded in the inside of it. So it uses AI embedded inside of it and then reacts in our real world. So by using, and because of this it will be obviously faster and efficient, right? You already have seen Tesla cars, self-driven cars, right? So in that way real-time computing will be possible. And what is sensor fusion? See, when you are driving, when you have seen Tesla cars, they will use so many sensors to see what is in front of it, what is outside of it, accelerometer to find the speed of the vehicle. So everything will be measured using sensors. So all this will be fused and utilized for our purpose. And so when we are using AI, physical AI, you are not using clouds or servers. So what will happen? Obviously you are not using more energy, but your efficiency will increases, speed will increases. So physical AI allows us for these advantages, right? So let's see what are its applications. So humanoid robots. So this humanoid robots helps for us to take in elderly care or do daily tasks like cooking, cleaning or whatever it is, because let's say if you tell robo that do this work, it might not know how to do that. Then it will fetch the AI which is present inside it and learns from it and does the task. So with efficiency and speed, that is the important thing here. So that is one application. Autonomous vehicles, I have already told you that Tesla cars or self-driven cars uses physical AI. Disaster response. So there are certain places where people can't reach. Let's say we have earthquakes. So it's very risky. That time we can employ these robots to help us protect those people and take those people required to the hospitals. So sometimes when these disasters happen, even the robots are expected to think like humans and act accordingly. So how this comes? This comes from AI. So if you are giving physical AI, obviously when there will be connectivity issues in disasters. So if it is only AI, it has to connect to the cloud servers. There is no connectivity, so it's very difficult for us to solve that issue. But when physical AI is integrated, what will happen? Irrespective of disasters, so if we connect physical AI into robot, what will happen? The connectivity which was lost because of the earthquake will not help us. So this physical AI, since it is integrated into the robot, this will not create any problem to act, because it will take the information what is present inside it and act accordingly. So it is used in disaster response as well. Let's see elderly care and logistics. What is elderly care? So there were many people who cannot have people to take care in their old age. So they will be sent to old age homes. So when we have this robots which uses AI, physical AI. So they'll have humanistic approach to help them. So they don't, the problem of dealing with old age people will be reduced, especially when they don't have anyone to take care of. These will be very helpful. So next, see what is the prelims relevance for our exam. Physical AI gives us to integrate AI into physical machines and then utilize this for our many problems, and we will be finding solutions for our problems, which helps us enabling AI to take decision making when and where required and to solve real world problems. Okay. Now let's move to next topic. Shinkansen technology. What is Shinkansen technology? So why it is in use? So Japan is giving 2 trains for India, E3 and E5 series at free of cost. So what is so special about Shinkansen technology and why it is used? To avoid train accidents. So Shinkansen technology helps us to avoid train accidents. So Japan is helping us by giving 2 trains, E3 series and E5 series free of cost in 2026. So this is E3 series train and this is E5 series train. If you see this, E5 series train is more faster when compared to E3 series train. So Mumbai-Ahmedabad bullet train project. What is this project? It is India's first high-speed rail project. So Shinkansen technology is used here. It is India's first high-speed rail project. It uses Shinkansen technology. And who does this? Who involves in this? NHSRCL. This involves and implements this projects. And funding. Funding is mostly done by JICA. JICA is nothing but Japan International Corporation Agency. Here we are not taking the help of World Bank but JICA. 80% of funding comes from JICA. Okay. So this Shinkansen trains, our Ahmedabad project, corridor project, deadline is 2028 and it is included in our NRP, National Rain Plan. Okay. So how it is important for our prelims? So Shinkansen trains are not maglev systems. So UPSC might ask this, Shinkansen trains employs what? Maglev systems and linear induction motors. Then the statement is wrong. Shinkansen technology does not use maglev systems. Next, E5 series is faster than E3 series. And the project is Japan funded. 80% comes from JICA, not the World Bank. Next, this is implemented by NHSRCL. So Indian Railways is not directly involved in implementation of this project. So what is? Let's see one line revision. This Mumbai-Ahmedabad project is funded by JICA and scheduled for completion by 2028, which uses Japanese Shinkansen technology, and Japan is donating 2 trains, E3 and E5 series trains. Okay, next topic is India's tokamak program. So what is tokamak? So what is tokamak? Tokamak is a machine which uses nuclear fusion reaction for our energy production. So what is nuclear fusion reaction? Nuclear fusion reaction is where two atoms combine and produces energy and releases energy. So this will happen at high temperatures, more than sun. The temperature requirement here is more than sun. So imagine if that much temperature we have to imitate on the earth, if we have to generate on the earth, is it possible for us to confine it in some place where some walls are there? Any metals, they will melt and they will damage with that high temperature. So we'll be needing some energy to confine that temperature, that gas. So what gas is used here? Plasma. Plasma is fourth state of matter. So what are other three states of matters? Solid, liquid, gaseous. So what is the need for fourth state of matter? Plasma. So this plasma is present in sun and any other stars. So in this plasma what happens? Nuclear fusion reactions takes place. So when two atoms combine, like tritium and deuterium, when these two atoms combine, energy is released. That energy is called nuclear energy. So this tokamak program helps us to generate nuclear energy. How? This tokamak uses toroidal shape, means donut shape. If you have eaten polo, that peppermint, right, that will have like this shape. So this is donut shape. This will have same shape. So in this space, using the magnetic energy, this will confine the plasma inside it so that it will not touch the reactor walls and it will not destroy the reactor. So that is where tokamak comes in, and this tokamak word is Russian word. So our IPR, Indian Plasma Institute for Plasma Research, which is located in Gandhinagar, deals with multiple experiments on tokamaks to study our plasma behavior and to use it for our advantage. So what is Aditya U? Aditya U is the upgraded version of Aditya tokamak. So Aditya U tokamak is used to study basic behavior of plasma. So for experimental basic trace we have used Aditya, and this Aditya 2 is the upgraded version of Aditya, which is operational from 1989, and if you notice its plasma current is around 150 to 250 kiloamperes. So the remaining SST1, SST2, SST3, these are all uses steady state tokamaks. This is implemented. This uses plasma current of around 100 kiloamperes, wherein SST2 is in developing stage. It is planned. It is in planned and is under construction. It uses superconductors. So it uses superconducting tokamaks, and the plasma current goes up to 1 million amperes. And SST3 is futuristic. It's not implemented yet. It is futuristic, and it combines SST2 and SST2 and ITER. So what is ITER? ITER is the global project which is used to study tokamaks and to implement for net energy gain and for using as commercially available reactors for futuristic purpose. In this project, many countries involved. It is an international project which is located in France. So, India is also one of the member of ITER project which is located in France. So, in this SST3, since it is uses high temperature superconductors, and this will help us for ITER research which is global project. INSPARK. INSPARK is not India's project, it is based in USA. So, it is based in USA and it is done by MIT, Massachusetts Institute of Technology, and its objective is net energy gain. So, what is net energy gain? So, if you are producing that much high temperatures, we will be requiring some fuel to give that much of temperature. So, that much of temperature needs fuel, right? So, if you are using fuel to reduce some kind of, to produce some kind of energy, we will be calculating the difference. How much energy we are using to produce that much temperature to produce how much of energy. So, the difference, if it is positive, like if you are getting more energy than we have given to produce our nuclear energy, then we will be getting net energy gain. So, our goal is to get net energy gain. So, it is planned to be completed around 2030. So, it is a proposed fusion demonstration reactor, like to check whether we are able to gain net energy. That's all for today. Let's continue tomorrow. Thank you very much. For complete video, please click on the link given in the description. For more videos, please follow us on YouTube channel.